Hi, everyone. Take a moment. Think of your very largest databases in your environment today. Of those databases, how many of them happen to have a very large percentage of data that will never change again? Things like sales order history data, or maybe financial transaction information. And do you happen to need to query that data a lot? Generally speaking, no. You might need to look back at the last couple of months of trade data, transactional information, or sales order history, but do you really need to look at the last 10 years worth of that stuff? Well, why don't we just archive and clean that stuff out? It's bloating our database. Nope, nope, no, can't do that because, sorry, we need to run quarterly reports going back 7 years. We might get audited. We need to keep that data around whether we like it or not. So unfortunately, that results in extra bloat for our databases. And that bloat results in longer backups and restores, other operational headaches that have consequences around the size of our databases, or even from a query performance perspective. Many of us happen to have code that love to do full table scans, whether they need to or not, which results in more I/O work. Well, today, I'd like to introduce you to a solution to that, to help solve that problem. Data virtualization, presented to you in SQL Server 2022, backed by Everpure FlashBlade. Let's learn more. What is data virtualization? Let's take a table that contains mostly data that will never change again, and we're going to exfiltrate it out of our database, and we're going to convert it or materialize it as Parquet files. These Parquet files are going to be stored in S3 object storage. Now remember, S3 object storage doesn't mean that you have to store this data in the cloud. There are S3 object storage platforms that exist on-prem, like our FlashBlade, which is exactly where this data is going to go today. And then we'll be able to query it seamlessly with our T-SQL code using something called an external table and combine that with a partitioned view to combine our Parquet files and our current data that we want to keep adding to and inserting into. And as a result, our database is going to be a heck of a lot smaller, and that helps us out from an operational perspective and from a performance perspective. Let's see how this all works. First, I'm going to be using this simple cookbook demo database, and I'm going to show you the external data source that I have already created. This external data source, that's the underlying name of it, and here's its location, which is my FlashBlade, and I'm using an S3 access key that I've defined here as this particular credential. And then I've also defined what's called a external file format, and we're going to be using the Parquet file format today. And just to show you all of this works, I'm actually going to use a simple example using OpenRowSet to query a CSV file that also sits inside of one of my buckets on the FlashBlade. So as you can see, I can do this kind of really interesting ad hoc querying against CSV files that reside in object storage. But we can do a lot better than just CSV files. So let's see how all of this works. First of all, I'm going to show you the reviews table. I'll just do a quick select top 10 records out of it. And then I'm also going to show you the size of it and the data distribution by calendar year of this data. So you see that we have a bunch of different IDs in here for the recipe that is associated with, the author who wrote it, the rating that they happen to have given for that given recipe, and other information, including a lot of text information of the recipe review itself. And we see that this table contains 1.4 million records. And finally, we see that it contains many years worth of data. The most recent year being 2020. We'll pretend that that is the current period of time, even though we know it's not. But let's just pretend with me that it's currently 2020. Haha. And if we go back, we see that this data goes back 20 years to the year 2000. We also, more interestingly, see that the heyday of this particular website was really in the 2005, 2006 through 2010. So there's a lot more data back then. That's older data. That's again never going to change. But do we really need those recipe reviews as often? Because our metrics show us that we really hit recipes only in the last 3 years worth or so. It's really uncommon for us to hit recipe reviews much older than that. But we have to keep it around anyway. So what we're going to do here is we're going to use CTOS, or create external table as select. And my select statement is going to select data out of the reviews table where year submitted is less than 2018. And I'm going to create this external table inside the schema called Parquet demo. I'm just using a separate schema here, more for organization purposes because this is a demo. And I'm just going to call it this particular table name reviews 2017 prior Parquet. It's just named this way more for example purposes. In addition to that, I'm also going to take the remaining reviews and move them into another static table. We're going to pretend that this is our current data table. So it's going to be called reviews 2018 present. So let's run all of this together. And this will take just about a moment or two, even though it's 1.4 million records, and we're done. And we see that of the 1.4 some odd million records, most of it got moved into Parquet. And it only took about 4 seconds or so. And about 45,000 records are now remain in our current table here. And finally, what I'm going to do is I'm going to create a partition view that's going to combine the Parquet external table and the current base table, which is the 2018 and present data here. Now, in a normal environment, I would also swap this out. Instead of using a separate schema, this would actually replace the DBO reviews table. But again, I have to keep this side by side for demonstration purposes because we're going to do some demos down here. But let me just do a quick side by side count of each of the two different tables, or pseudo tables as it is now, because it's a bit of a hybrid being a partition view. But we see that we have the same 1.4 million records in each of them. And then I'm also going to show you the external table definition. This is the name of the external table. It resides on my FlashBlade in this particular location on the FlashBlade. And in fact, I can even go into the S3 browser here and jump over to Pure 360 Demo, jump into reviews, and see that there are 4 Parquet files that have been created of the underlying data records here. Pretty cool. Now, let's do a little bit of query testing here. I'm going to turn on set statistics time on, and we're going to do just kind of an interesting aggregate query where we're looking for reviews across multiple different years. We're going to do some averages and other calculations here just to try and find some information here. And let's see how this aggregate query happens to perform. They both executed pretty quickly, and from a duration perspective, the first one, which ran against just a regular old single table, took 105 milliseconds. The second one took a little bit longer, yes, but keep in mind, working with Parquet is not necessarily a performance play. This is one to try and help out the operational situations, and on the occasions that you do need to go after that older data, well then, yeah, that might take a little bit longer. But if we were only going after newer data that's in 2018, I don't even have to touch those Parquet files. And we'll get to understanding why that's the case a little bit later. And that's where there's going to be huge benefits from a performance perspective. If I were to just have queried instead of 2013 through 2019, just show me everything from the current data of 2020 and more recent. For example, I don't even need to touch those Parquet files, and they are out of my database. Speaking of being out of my database, how much storage did this actually consume? The 1.4 million, in this case, about 800 megs. But now with the 2018 to present table, now I'm only looking at around 45,000 records and around 22 megs. A tremendous savings as far as from a percentage perspective, as far as reducing the size of the underlying table and reducing the amount of data inside my database. Well, Andy, you might say, this is a really, really small table. Why don't we look at something bigger? And we shall. So what we happen to have here is a much, much larger table inside the FT demo database. I'm not going to run this select count query right now because it will take a bit of time. But as you can see here, I have order data that spans from 1992 to 1998. And each calendar year happens to have a couple hundred of million records inside each calendar year. So a heck of a lot more data in this particular case. I have already pre-created my partition view and created my Parquet files. In fact, let's take a quick look at them here in the S3 browser up here. So I happen to have a whole bunch of different Parquet files in here. There's 16 files to be exact. And if I go up to the underlying folder here, I can see the summary. The total size of this is about 102 gigs of Parquet data. And let's compare that to the sizes of the base tables underneath. So we started with 1.5 billion records of orders, which total about 180 gigs. The remaining data that resides inside my SQL server is still 43 gigs in size. 43 plus what, 102 or so? 145 gigs. So we were able to realize even more savings underneath the covers because of the Parquet format, because the data inside Parquet is compressed. So that's also a really cool benefit too. Oh, and by the way, it gets even better. Because when I look at the FlashBlade, remember how it's 102 gigs on the FlashBlade? We have data reduction on the FlashBlade. So really on the FlashBlade, I only burned down just under 42 gigs worth of capacity. So that's even better. So even though it's compressed data, the Parquet files, we're still able to data reduce it yet even further and realize even more savings on the FlashBlade. That's super impressive. Now what I'm going to do a simple sample query for you is that I'm going to just grab the top 200 records out of the orders table, and now I'm going to grab customer keys. I'm going to grab 3 random customer keys. I have no idea how this is going to turn out. I kind of do actually, but three random customer keys here, and then I'm going to copy and paste that into a set of side-by-side queries here. This is just a simple select top 1000 star from the Parquet demo orders and then the DBO orders here. And to make this even more challenging and make sure that I have no tricks up my sleeve, I'm going to drop clean buffers, issue a checkpoint, and free the proc cache. This should take about 2 minutes. So in the meantime, while this runs, I want to explain to you why are we using Parquet and why are we using S3 object storage in the first place? Because Andy, didn't you show us earlier that you use a CSV file? So here's the thing. Parquet first is compressed. We already saw that. But the data inside Parquet files is also physically stored in a columnar format. This is particularly useful for columns of data where there's a lot of repeating information. Date time, like order dates, is a fantastic example of this because with order dates, there's only a finite number of possible dates that a given value could possibly be. So that is something that compresses really, really well. The data physically is also broken up into chunks, which we like to think of as row groups. Think of it simplistically. Maybe I happen to have 1,000 records, such that I'll have row group run of record 1 through 100, and then another row group of 101 through 200, and so on and so forth, in these different chunks. And then it's chunked out in a columnar format. But the key here is that we also store metadata for the groups of underlying data. So I know the mins and the max values for each given row group for each given column. So if we're looking at order data, for example, a given row group might have April 1st as its min value and April 17th as its max value. So I know that row group only contains data between for orders between those two different dates. And then for each of those different row groups, we also have physical byte ranges within the given Parquet file. Why is all that important? That's where the other half of this comes into play, the S3 protocol. Because the S3 protocol is able to take that metadata information and issue requests not for an entire file, but for chunks or subsets of a file using the byte ranges and the byte offsets. So therefore, we just read the metadata first. We know what predicates we're looking for the underlying data. And then now we can issue not just the one, but many S3 requests simultaneously, enabling us to do parallel seeks into the underlying Parquet files. So you saw earlier in the S3 browser that there were 16 Parquet files of 6, 7 gigs each, give or take. But now behind the scenes, I'm issuing hundreds, if not thousands, of S3 requests that are very granular seeks going into specific row groups. And if I did a select star, but if I was only selecting maybe 3 columns of the underlying data, I could do even more granular seeks because I'd only need column 1, column 5, and column 7 rather than just doing a simplistic select star and giving me all of the columns. Think of this as the functional equivalent of doing a whole bunch of index seeks within SQL Server rather than range scan operations or avoiding the dreaded full table scan. I see our example query has completed, so let's look at how long it actually took. Well, first of all, this example only returned 30 records each. 30 records out of the hundreds or 1.5 billion in sum total. That's quite a bit. We're definitely trying to look for a needle in a haystack kind of scenario here. And how long did this actually take us to run? The first query against DBO orders took almost 60 seconds. Okay, how long did the other one run? 42 seconds, just over 42 seconds. That's actually an improvement here. Pretty cool, huh? Just because we were able to, again, go after a much smaller subset of our underlying data. So I hope this little introduction to SQL Server 2022's data virtualization really gives you an idea of how we are able to combine the power of CTOS, Parquet files, and S3 object storage on FlashBlade to reduce our database size and enable us to still query that underlying data in a reasonably performant manner using our existing T-SQL. Next, I dare you to give this a shot yourself. We have a test drive available that happens to have this functionality set up for you, and a work lab that you can walk through the different steps to try this out for yourself. Hope you have fun, and until next time, we'll see you soon.